find the directions in which the function f of xy is equal to x square plus y xy plus y square increases and decreases most rapidly at the point p0 of minus 1 1. Then find the derivative of function in these directions. Now they given that function f of xy is equal to x square plus xy plus y square. To find the directions in which the function increases most rapidly or decreases most rapidly, first we should find the gradient vector of this function. Gradient of f is equal to daba f by daba x into I plus daba f by daba y into j. This is partial differentiation of whole function f with respect to x, and partial differentiation of whole function with respect to y is daba f by daba y is equal to partial differentiation of x square with respect to x is 2x, and partial differentiation of xy with respect to x is y, and partial differentiation of y square with respect to x becomes 0 because y square is considered as constant while partially differentiating this with respect to x. Now whole differentiation of partial differentiation of function f of xy with respect to x is 2x plus y into j. This is daba f by daba x is equal to 2x plus y into I plus partial differentiation of x square with respect to y is 0 because x square is considered as a constant while partially differentiating this with respect to y. Partial differentiation of xy with respect to y is x, and partial differentiation of y square with respect to y is 2y. This is x plus 2y is daba f by daba y and into j. Now we find the gradient vector of function f at the given point of minus 1 1. That is, gradient vector of function f at minus 1 1 is equal to, that means in the place of x we should put minus 1 and in the place of y we put 1. If x is minus 1, 2 into minus 1 is minus 2 and plus 1 is becomes minus 2 plus 1, that will become minus 1 into I plus in the place of x is minus 1, in the place of y is 1, 2 minus 1 becomes 1 into j is equal to minus I plus j. This is gradient vector of function f. Now we find the direction of gradient vector f. Direction of gradient f, that is equal to the function, the vector gradient vector f divided by modulus of f, magnitude of gradient vector f. The gradient vector of f is minus 1 into I plus 1 into j divided by magnitude of this vector is square root of sum of squares of coefficients of I and j. That means minus 1 square, this square, plus 1 square, that is equal to minus 1 into I is minus I, 1 into j is j plus j divided by minus 1 whole square becomes plus 1 and 1 square is 1. 1 plus 1 is 2, so root 2. This is the direction of gradient vector of f, that is denoted as u cap because this is a unit vector of gradient vector of f. This is denoted as unit vector. Now we get gradient vector f at -1 is minus I minus plus j, what we get, and direction of gradient vector is equal to minus I plus j divided by root 2. What this is equal to unit vector u cap. Now we should find the derivative of f of xy in the direction of gradient vector f. Derivative of function f of xy in the direction of gradient vector of f, that is equal to gradient vector f at -1 1 into unit vector u cap. This is formula for directional derivative. So derivative of function f of xy in the direction of gradient vector f is gradient vector f at -1 1 into direction of gradient vector or into unit vector. This is equal to gradient vector of f is minus I plus j into unit vector is minus I plus j divided by root 2. Then we get I minus I into minus I is plus 1 and j into j is plus 1. I into j and j into I becomes 0 divided by root 2. This is equal to 2 by root 2 equals to root 2. So we get derivative of f of xy in the direction of gradient vector is equal to root 2. Now we get directional derivative. So in the question they given that find the directions in which the function f is increases and decreases most rapidly. The direction of function increases most rapidly is the direction of gradient vector. The function is always increases in the same direction of gradient vector. So this direction is equals to minus I plus j by root 2. That is what we find. Always the function increases in the same direction of gradient vector. This is the direction of gradient vector, so it is equal. Then derivative of f of xy in the direction of function increases most rapidly is equal to we know that direction of function increases most rapidly is minus I plus j by root 2. In this direction, derivative of function is root 2, what we had done. Then derivative of function f of xy in the direction of function increases most rapidly is derivative of function at this direction. That means that is equals to root 2. Then another question they given that direction of function decreases most rapidly. That is equals to opposite direction to the gradient vector. That means minus of minus I plus j divided by root 2. That is equals to I minus j divided by root 2. In this direction, function decreases most rapidly. And another question, derivative of f in the direction of function decreasing most rapidly. That is equals to negative of this derivative root 2. That is equals to minus root 2, because this direction is opposite to the direction of function increasing. So it is minus root 2.